Today I'm going to talk about Smoky Face, a project by Yan Jiefeng and Shijing Liu for CIS 563. In this project, we have implemented smoke formation and transformation that can be applied to complicated targets such as human face. More specifically, we added driven pressure terms and momentum terms to a common Navier-Stokes equation. We modify density according to the height fields algorithms. In addition to this, we utilize image segmentation algorithms to refine smoke transformation between two complicated geometry. Being different from common Navier-Stokes equation, our velocity was updated by a driven pressure terms, which drives the strokes to move to a direction with weaker density, and the momentum terms, which allows the smokes to somehow move out of the shapes for better visual effect. On the basis of these updates, we limit the smoke's velocity by a parameter which we extract from sample images. Our density is also modified in a way that the density of closer grid will be restrained by a smaller limit, whereas the density of farther grids will be restrained by a bigger limit. The density greater than the limit will be gradually reduced until it's less than the limit. In order to produce better smoke transformation between two human faces, we segment each face sample pictures into 19 triangles. For each grid in the source, we figure out which triangle it belongs to and its corresponding position in target triangle. Then we interpolate the source position with target position and source density with target density to obtain the intermediate position and density. Finally, we assign the intermediate density to the intermediate position. In our system, we started with update source. Our source will only last for 20 frames. Then we advect velocity. And thirdly, we update velocity with driven pressure and momentums, and also restrain the velocity by corresponding image parameter. And the fourth, we interpolate position and density according to the image segmentation. Later on, we modify density according to the depth, and finally, we advect density. Now here comes a simple transformation between two Chinese characters. Smoke started from the formation of a Chinese character, Shen, and then transformed to another Chinese character, Feng. Then we demonstrate smoke formation in both 2D and 3D. It started from the smoke formation of Yan Jie's face in 2D. And then its smoke formation of my face also in 2D. The third one is a smoke formation of Dr. Lane's face in 3D. The last one is a smoke formation of Joe's face in 3D. Finally, we demonstrate the complicated smoke formation and transformation in 3D. It started from the smoke formation of my face in 3D. And then my face transformed into Yan Jie's face. Thirdly, Yan Jie's face transformed to Joe's face. Finally, Joe's face transformed to Dr. Lane's face. For the future work, we need to recover the nature of smoke during transformation. We also need to research better image segmentation algorithms. And finally, thanks very much to Joe for all the guidance.